Today we're going to talk about relationships between categorical variables. So we know about relationships between quantitative variables, like height and weight, or years of education and income. That's what we use correlation and regression for. But what about relationships between categorical variables? For example, is the relationship between someone's college student's academic major and favorite kind of movie. Maybe science majors like science fiction movies more than non-science majors. Or between whether someone is a man or a woman and whether or not they regularly exercise. Between whether someone is left-handed or right-handed and whether they participated in college sports. We're looking for relationships, and we'll see what those things might look like. And the way we answer these questions is with what's called two-way tables. So let's look at an example. Is there a relationship between someone's general level of health and whether or not they've exercised in the last month? And we'll use our health data to answer this question. So when we filter their health data and break it up by whether or not they've exercised and what kind of health they're in, these are the numbers we get. Okay, so what good does that do us? Well, we're going to make pie charts for both groups, for those who've exercised and those who have not exercised. And these pie charts are a good way of seeing what looks like a relationship. Look at the people who have exercised. Looks like about 2/3 of them are in either excellent or very good health. That's a much smaller percentage than the ones who haven't exercised. And that's not surprising, of course. Exercising helps your health, and those people who are in poor health aren't well enough to exercise. So what does the relationship look like? It looks like the pie chart is different. The health pie chart is different depending on whether or not you've exercised or not exercised. Those who have exercised are more likely to be in the top two levels of health and less likely to be in the bottom two. So again, here's the raw data. And the numbers alone are hard to look at and decipher because there's just so many more people who have exercised than who have not exercised. So instead, we look at the proportions. We say, okay, there were 767 exercisers, 197 of those were in excellent health. That's 0.26 as a proportion. That's 26% of them. There were 233 non-exercisers, 16 of those were in poor health. As a proportion, that's 0.07 or 7% of them. And if we compare the first two lines of this table, the exercisers and the non-exercisers, the totals don't do a whole lot for us here, actually. If we compare the first two lines of this second table, we see that only 2% of the exercisers were in poor health and 7% of the non-exercisers. So you were 3.5 times as likely to be in poor health if you had not exercised. Or 26% of those who had exercised were in excellent health compared to only 19% of the non-exercisers. So by looking at the table of row proportions, it looks like there really is a relationship between them. Now, another way we can look at it is to find out how many we would have expected in each of these cells, in each of these sections, if there were no relationship. And these expected numbers, they're a little confusing, but let's see where they come from. 767 out of 1,000, that's 76.7% of your whole sample had been exercisers. If exercising and health had nothing to do with each other, you would expect that 76.7% of this 241 would also be in excellent health. And if you take 76.7 of 241, you get 184.8. So the way to get these expected numbers is take the total of the row, 767, times the total of the column, 241, and divide by 1,000. That's where this 184.8 comes from. Take the total, so for this one, no exercisers in poor health. The total of the row is 233, total of the column is 30. Multiply those together, divide by 1,000, and you would expect 7. Why is that? Well, 23.3% of everybody had not exercised, and 23.3% of 30 is 7. And again, by comparing these numbers up here, what we actually got, to what we would expect if there was no relationship, this also indicates that, yeah, there really is a relationship. We expected 7, we had 16 in poor health. We expected only 184.8, of these people, of the exercisers, to be in excellent health, it was actually 197. So that's just another way of looking at the data and deciding whether or not there's a relationship between these two categorical variables. Now, of course, this was just a sample, 1,000 people out of the hundreds of millions of adults in the country. Later in the course, we'll see how to make a decision whether this is just sort of random variation of having gotten these 1,000 people, or whether it really indicates that there's something going on. Now, this isn't an assignment, but as a challenge, see if you can do everything that I just did to see if there's a relationship between health and whether or not someone had smoked 100 cigarettes in their lifetime, or between health and whether they're a man or a woman. So see if you can do all these parts. Get the data by filtering, make side-by-side pie charts, and look at the pie chart and make a judgment. Make the table of row proportions. So again, once you have the data, you look at each section and find out what proportion of its row it is. And then challenge yourself to see if you can get these expected values. Row total times column total over grand total is the expected.